In this unit, we will examine how we can fetch data that resides on a local file system. We can find and list files based on their type, their name, or even their creation, access, or modification time. We can execute commands based on the files we have found, and we can also list details about those files. When the data we want to find reside in files on a local file system, then the find command is the one we want to use in order to locate the files that interest us.
As an example, let's move to the user directory. Under user, I run the find command. In its most simple form, find receives as an argument a directory and outputs the files of the whole directory hierarchy. Here, I specify the current directory with dot. I pipe the output to head, and we see the various directories that exist in USR, such as games, lib, and the subdirectories of lib.
We can change the behavior of find based on a wide set of options.
By specifying the f argument to the -type option of find, we can restrict the output of find to only include plain files. In this way, I run find on the current directory, including the type f option. We only get files in the output now. The directories we saw in the previous example were not displayed.
The file type option also allows us to search only for directories.
Correspondingly, -type D stands for directory. Using this option with the find command, we now only get directories in the output.
We can use the name option in order to find files whose name matches a specific wildcard pattern.
With find's -name option, we can specify a pattern to match file names. For instance, I choose to find in the current directory hierarchy only finds that end with the suffix .a. Note that I quote the wildcard because otherwise it might expand to such files in the current directory and thereby arrive as an incorrect argument to find. As the command's result, we see all files that end in .a in the directory hierarchy.
We can also combine options, which means that all of them must be true in order to find to list the file or do something else with a specific file.
To see an example, I first run find on the current directory. With the name test option, I restrict find to only look for entries named test. The output we get includes both files and directories. In order to limit the output to only list files, I also include the type f option we've seen in the previous examples. We noticed that there is only one file named test in our output.
Some options perform action rather than specifying or restricting what files find will list. Note that find by default will print the name of each file it has found. This was not the case for many years, and a common error was forgetting to add the print option to your find command. Nowadays, the print option can be left out.
Here, I use the type F and ls options to get a long listing of each file found in the directory. In this way, instead of simply displaying the file names, we also get complete details for each file.
The most general action is exec. This allows us to execute any command we want. Note that this is rather inefficient. There are better ways to execute a command on many files, which we shall see later on.
Let's see an example. I search in the directory user shared doc for all files named changelog.gz. For each file, I execute a command to decompress it. For that purpose, I use the exec action of find. The arguments of the exec action are a bit cumbersome. After -exec, we specify a command we want to run for each matched file. Typically, the specified command also has its own options. In our case, I use the gzip command with the DC options to decompress the matched files on the standard output. I complement gzip to use as its argument a set of open and close curly braces in quotes. The find command will replace these braces with each matched file before executing gzip. Because the curly braces have a special meaning to the shell, we need to escape them in single quotes. Finally, we denote the end of the command arguments of exec using a semicolon. This also has a special meaning in the shell and needs to be escaped with a backslash. To sum up, the exec action decompresses every file named changelog.gz under the directory user share doc. Then it sends the output to the standard output. Piping the result of all these executions to wc-l, we get a total number of lines. We see that there are about 3 million lines in all these files.
Let's now see a more complete example where we will combine multiple options.
Let's look at a more complex case. I want to find and list the C header files of the directory user include. Running find on user include and specifying to only look for files, we indeed get the C header files, for example ustart.h. But we also get the C++ header files, such as the C++ cstd-align header. These need to be filtered out because I'm only interested in the C header files. To do that, we can combine two predicates of find. I run find on user include, first specifying that I want all files whose name includes C++ to be pruned, in other words, to be excluded. As prune evaluates to false for non-pruned elements, next I type -o, which means or, to include all other files. Using the print action, I print these. In this way, we only get the C header files after pruning the C++ ones.
This concludes our unit on fetching data from the file system. Stay with us.